This series of e-learning videos is used in conjunction with the printed participant guide for refrigeration, defrost systems, and airflow and electronic controls training. If you don't already have it, please ask your manager for a printed copy of the participant guide for you to follow along and to fill in activity information. Prior to taking this course, you must complete the following prerequisites. In Segno e-learning, in-home technician safety, refrigeration basics, common refrigeration issues, acetylene oxygen safety training, flammable refrigerant safety and policy, flammable refrigerant safety and awareness, and BECT2 instructor-led training. This is part 1 of Refrigeration Training Module 4, Defrost Systems, Airflow, and Electronic Controls. It is recommended that the modules be taken in the order shown. In this course, you will learn how to explain internal airflow within a refrigerator or freezer cooling system, describe the purpose of air dampers, explain the operation of the defrost system, and diagnose using defrost sensors and electronic controls. If a complaint involves an incorrect compartment temperature of too cold or too warm, and you have eliminated the sensor circuit as the cause, an airflow issue is the next logical consideration. Internal airflow is critical and distributed by fan and regulated in the fresh food compartment by a damper in most single evaporator designs. The example shown here is of a single evaporator bottom mount freezer model with the damper control located at the top of the supply tower in the fresh food compartment. In addition to supply, returned air is required, similar to air conditioning. Both must be present in order to change the air in the compartment or room. Other than the very basic models, air dampers are automatically controlled. The automatic damper can be driven by an AC motor or DC motor or a stepper motor. A less common method is thermostatically controlled. This is one example of a motorized damper which uses an AC motor with a position switch. The position switch is also line voltage AC, but it is used as a logic feedback to tell the control board which position the damper is in, either open or closed, nothing in between. This is also a motorized damper, but it uses a stepper motor. Stepper motors have more than one winding and receive DC pulses from the control board. Each pulse rotates the armature a few degrees. The low voltage coils are energized by the control board in sequence, allowing the rotor to be stepped to a predetermined position. This particular configuration of stepper motor receives 4 pulses before repeating the process for continued seamless operation. The first 2 pulses are in one polarity, the next 2 pulses are in the reverse polarity. The pulses occur much more quickly than shown here, and therefore a voltage check with your typical meter is not possible. You can, however, measure the resistance of each winding with the motor disconnected from the circuit. Airflow and damper problems are frequently caused by frost. The frost is typically a result of excessive moisture from air leaks or excessive door openings. Moisture and frost are typically what cause a damper to fail. Moisture can easily migrate into a refrigerator or freezer compartment through any air leaks and become frost or ice. These photos show different areas where leaks can occur and where frost may accumulate and cause issues with the damper or airflow. Don't forget about the return air grill and duct, as ice or frost here will cause warmer than normal temperatures in that compartment. Be cautious when defrosting ducts, as even a steamer can saturate styrofoam or warp thin plastic. Removal of any frost accumulation is necessary, but that in itself may not resolve the root cause. The source of excessive moisture must be determined and corrected. There are three basic high-level steps to follow when diagnosing a refrigerator or freezer for a cooling problem. Check the simple things first. Observe which components are operating and which are not. What condition is the evaporator? Is it frosted up? Check the evaporator for a frost pattern or for too much frost. Included in the simple checks, what responses has the member given you to your questions? Is the power supply correct? Check the compartment temperatures early and at the first door opening. Are the controls settings correct? Ambient conditions should be within normal. Have you eliminated door problems? The light should turn off, of course, when the door is closed. Do you hear any abnormal sounds, or has the member heard any? Again, always rule out the simple things first. As you gather the clues, it is beneficial to note which components are operating versus those that are not operating. For example, in this very simple diagram, consider these two scenarios. Number one, there are no loads operating. Which components could be causing this? It could be the thermostat, timer contact. The timer could be stuck in defrost. Or it could even be the power supply or a connection from the power supply. Now in scenario 2, the fan motors are operating, but the compressor isn't. What could be the likely cause? Well, it could be the overload, could be the compressor itself, could be the PTC relay or a connection within that branch of the circuit. Remember though, the compressor has the largest demand on the voltage supply, so don't rule out that until you have measured voltage as close to the compressor during an attempt to start. Next, we will cover the scenario of all cooling components operational and the poor cooling complaint appears to be related to air circulation. Note that service manuals often have illustrations showing how the air should circulate. This can be beneficial when some compartments appear to be cooling properly while others are not. Also note the different types of refrigerators, side by side, top mount, and bottom mount. This bottom mount happens to also have dual evaporators. When a bottom mount has two fresh food doors, it is called a French door model. A reason for lack of internal airflow can be a failed defrost system. Frost buildup on the evaporator coil will also reduce heat transfer. In this scenario, you have determined a lack of airflow due to the excessive frost on the evaporator cover, and you have advanced the timer manually to initiate a defrost cycle. Now, how do you determine if the heater is actually operating? The answer to that question is to check for heater current. Place your ammeter anywhere in the heater circuit that is convenient. What could be the issue if the heater is actually on after manually advancing the defrost timer into a defrost cycle? The likely answer will be the timer, since it doesn't seem to be advancing on its own or initiating a defrost cycle on its own. However, a weak defrost bimetal can be misleading. While the defrost timer could indeed be the issue, another cause could be a weak defrost bimetal. You should allow the defrost cycle to continue while monitoring the current. You could do this while you disassemble the evaporator cover and you can begin defrosting the evaporator manually along with the defrost heater helping, but don't put any direct heat onto the bimetal. This way you can see if the bimetal is cycling prematurely. And just because a bimetal looks good doesn't mean that it is. If the defrost current stops with the bimetal still encased in frost, and it's still in a defrost cycle, this indicates a weak bimetal, and you can verify that it is the bimetal with your voltmeter. Please note that if you do see a bimetal in this condition, remove the power before touching it, as water may have already entered it and it is a shock hazard. Be aware that the refrigerator will normally remain in the defrost mode for a few minutes after the heater has turned off or cycled off to allow for defrost water to drip off the evaporator and into the drain pan before starting the compressor. If your ammeter indicates the defrost heater did not come on, you will need to make voltage checks in the heater circuit in order to find the fault. To gain access for electrical diagnosis of the defrost circuit on the model depicted here, the control console can be lowered from the ceiling of the fresh food compartment. 2 screws removed will gain access to the following components and voltage access points: the thermostat, the timer, and the test terminal. Test terminals have been provided on non-electronic Whirlpool-made refrigerators for many years, which makes it possible to make voltage measurements across the entire circuit without physically accessing the heater in the bimetal. A step up in the efficiency from the electromechanical defrost timer is the adaptive defrost control. The adaptive defrost control uses several inputs to adjust the frequency and length of the defrost cycle. How long it takes for the defrost bimetal to open on the prior defrost, runtime of the compressor. Some even monitor door openings through the light circuit. Just as the defrost timer, the ADC initiates the defrost cycle and is diagnosed in the same manner as the timer using the BECT 3-step process. The test terminals that are shown on the diagram do not exist in many cases. Now you will apply your basic electrical troubleshooting skill to a refrigerator that is not defrosting. This is an in-book activity. Locate the page in your participant guide, and together we can answer the questions. You may pause the video as needed. Review the activity with your mentor or trainer and ask any questions you have. Using the BECT 3-step process and the ADC circuit, answer the following questions in your participant guide booklet. Question 1. What is the inoperable load? Well, since it's frosting up, not defrosting properly, that would be the defrost heater. Now trace the circuit for the heater from both sides in 2 colors, just as you did in BECT2. It is helpful to know that the ADC board uses a relay between P6 and P7 to complete the circuit when initiating a defrost cycle. So hopefully yours looks like this one. In this scenario, the evaporator cover is full of frost and you have initiated a defrost cycle. Question number 2. How would you know if the defrost heater is functioning without seeing it, hearing it, or feeling it? As stated before, the heater current can be measured anywhere in the heater circuit. Where could all of the electrical circuit checks be made? The ADC board is the logical place since this is the hub of most of the circuits on the refrigerator. Where could you place your black meter probe to serve as a neutral tag? Let's consider this for a moment. The ADC board needs a neutral to have power anytime the refrigerator is plugged in, and this is available at P4, a white wire. This will be the tag for all references to 120 volt checks. Where could you place your red meter probe to check for source voltage? The answer is P6 on the ADC board, the black wire. The voltage level, polarity, and proper ground measurements can all be taken between these 2 points and cabinet ground. If these are incorrect, you will then need to access the power cord or the wall outlet to determine the source of the issue. The next step is the BECT process that requires a check for the proper voltage at the defrost heater, which unfortunately is currently buried in ice. Where could you place your red meter probe to check for voltage to the heater without removing the evaporator cover? If we consider the brown wire as an extension of your red meter lead, P2-2 or P2-3 on the ADC board connects with the line side of the heater. Your black meter lead is already on the neutral side of the heater. You should measure line voltage here, but if line voltage is measured and there is no current, this would indicate an open heater. Keep in mind that once the evaporator is defrosted enough to access the heater connections, you should make a voltage check right at the heater to eliminate all connections between the ADC and the heater as the cause. If line voltage is not measured here, follow the BECT process to walk the red meter lead back toward the source of line voltage to determine where the open circuit is. In order to walk the circuit, the black meter probe can remain as the tag. The next test point is the line side of the bimetal, which is the pink wire at the board at connector P7. So the red meter probe is relocated there to get a reading. If line voltage is now measured here, this indicates an open bimetal. But if 0 volts is still measured, continue to walk the circuit toward the source of line voltage, which is the line input to the ADC board, P6, the black wire. This was done previously when the source voltage was tested, but just to be sure, relocate the red probe there and line voltage is measured. With 0 volts at P7 and line volts at P6, this indicates an open relay on the ADC board. However, you must ensure that the ADC is indeed in a defrost cycle in order for the relay to close. To recap, the open component will be indicated by the voltage going from 0 to line voltage as you walk the circuit from the line side of the load toward the source voltage. In order to use the BECT process to diagnose a problem with the defrost cycle, the refrigerator must actually be in a defrost cycle. Now, a defrost timer can be manually rotated to the defrost position, but how is that accomplished on this one? You can use media search to open the tech sheet to determine how to put this model into a defrost. Take notice of a service flash that addresses an incomplete defrost issue, but for now we'll just go ahead and open the tech sheet. We see that there are actually 2 options to energize a defrost cycle. When may you want to use one over the other? Option 1 requires unplugging the refrigerator, and option 2 does not, you may want to consider trying option 2 first, especially if the refrigerator would need to be pulled forward to unplug it. Try to minimize moving the refrigerator whenever possible to reduce the possibility of property damage. Please also note that if the bimetal is open, the ADC will not stay in defrost for very long. In fact, it is beneficial to have your meter probes and amp clamp already in position so that readings can be taken as soon as the defrost cycle is entered. Note that some meters, like the SC56, have a dual display that allows voltage and current measurements at the same time. Also note the bimetal may be temporarily jumpered to check operation of the rest of the circuit, but do not allow the evaporator area to overheat, and do not forget to remove the jumper. Also, be aware that some Whirlpool manufactured product incorporates a pulsed defrost programming in the electronic control. This program turns the defrost heater on and off during a defrost cycle. Therefore, the current and voltage to the defrost heater will not be on steadily throughout the defrost cycle. Electronically controlled refrigerators operate a bit differently than electromechanical models. This is a Samsung dual evaporator, for example. The bimetal limiter or thermal fuse is still in series with the heater. However, the control board programming determines when the defrost cycle is initiated, and the control board then monitors the defrost sensor, which is measuring the evaporator temperature, to know when the defrost cycle is complete. The limiter or thermal fuse is only there for safety shutdown of an over temperature situation. Thermal fuses and some limiters are one-time blow and do not reset. Most of the bimetal limiters are in the temperature range of 140 degrees versus the defrost bimetal, which is in the 45 degree range. Most electronic models have forced mode to check the function of each of the components, including the defrost system. Follow the directions included in the text sheet for the specific model. Please note that before initiating a component operation mode, it is recommended that any error or fault codes be retrieved first, as sometimes the forced mode will clear any error codes. Manual frost removal is necessary even after you have repaired the defrost system. Frost remaining on the evaporator or in air ducts will generate a recall. Caution: excessive heat can damage plastic items such as liner and air ducts and fan blades. Avoid direct heat to thermal fuses or limiters when applicable. Heat can warp and melt plastic easily. A steamer is the preferred tool over a heat gun and can also be used to clear drains and remove ice from evaporator covers before disassembly. You still must use caution though, as some styrofoam air ducts can be permanently damaged. Also remember that thermal fuses are generally set to blow in the area of around 140 to 160 degrees. So what temperature is steam? Well, typically it's 212 degrees Fahrenheit. So keep your steam from directly hitting the limiting device. Otherwise, you might be replacing that as well. Keep in mind, the capacity of the drain pan is designed for less water than you will create when performing a manual defrost of a frosted up evaporator. So you will likely generate more water than the drain pan can hold. Where would the excess water go? That's right, all over the floor. So you could use your towel to collect it on the inside before it goes down the drain. That is a preferred method versus having to wipe it up off the floor. This concludes part 1 of defrost systems and airflow. and electronic controls. Please watch Part 2 at your next available opportunity to continue with this module.